this assessment asks us to show the mechanism of the reaction on screen. Now, in the reaction on screen, we're doing essentially a Grignard addition to an aldehyde, but in the presence of this chiral catalyst that's going to help us direct addition to one phase or another. The assessment tells us to ignore stereochemistry. There's another thing we can do when we approach these problems, and that is ignore the shiny objects. So a common way that students can get confused is looking at these molecules and think, wow, what a huge complex molecule to make some other new huge complex molecule. And look, to be honest, that's what makes me love organic synthesis, and someday hopefully you will too. But when you're first learning this material, it's hard to ignore everything that's going on. And so what we're going to do for this problem is to simplify it both in terms of what we have to draw, but also in the approach is we're going to see that most of this molecule is unimportant. What matters is only the aldehyde functional group, since that's what's going to be reacting with our Grignard reagent. And so we've numbered the carbons appropriately. Carbon 4 is still our aldehyde. Carbon 5 is the same CH2, but then we're just going to show the rest of it as R because it's just hanging out watching this reaction occur. Now, we can draw our Grignard reagent or think of our Grignard reagent as if it's ionic, an ionic bond between carbon and the magnesium bromide cation. This reminds us that that's a nucleophile. We can also take this aldehyde. We don't have to do it this way, but we can. We can take this aldehyde and draw what we call the Zwitterion resonance structure, where we put a positive charge on carbon and a negative charge on oxygen. This makes this mechanism really easy to draw because now we can just show this lone pair attacking the positive charge in this Zwitterionic resonance structure. When we do that, we'll draw our next product. We want to make sure that we keep our carbons numbered. So we'll do that 1, 2, 3. Here's carbon 1, carbon 2, carbon 3. We're making a new bond between carbon 3 and carbon 4. So we'll go up to carbon 4. We now have O-. Carbon 5 is here, and then our alkyl group. If we didn't want to use this Zwitterion form, we could have had this attack the carbonyl at carbon 4, so attack the aldehyde this way, and push those electrons. Either way gets us to here, and because these are both in the resonance hybrid of the aldehyde, either way of drawing these electrons is correct. At this point, we have the alkoxide. We're ready for our acid quench step, and so we can react with H3O+, simply protonating this oxygen. And when we do that, we make this product here. So what did we learn? This reaction is going to produce a new chiral center because of the chiral catalyst. But in terms of the mechanism and thinking about reacting complicated molecules, we can simplify it by just limiting it to what's reacting. This is the mechanism of this reaction.